Bonjour tout le monde, this is Peter Rosenthal here from COM225, John Molson School of Business. I hope all is well. I hope that you had a great snow day today and took advantage of either taking a little bit of a break or studying for your midterms, or ideally maybe a bit of both. And that's it. So yeah, let us know today. And just as a reminder, so it's Peter Rosenthal here. It's a picture of me. This is me on the ski hill not that long ago. Not today. Not today. I did some work today. But just to remind you that it is indeed Peter Rosenthal here. And today was a snow day. And this is the COM225, kind of the lecture I wanted to do today, cover the topics that I wanted to do in class today on probabilistic models of inventory management, probabilistic models on inventory management. So we'll do it in a bit of a virtual lecture mode here, virtual mode right about now. So let's do that. So just to get started, so let's do a bit of a recap. So last class, we talked about three different models. One was the standard EOQ model. Here's the formula, and here's the total cost. The second one was, if you remember, the EPQ model. Just clean that up. The EPQ model, which was more for production. And then the third model was known as the discount model, which is kind of based on this model, but we add another factor here, which is the price times the demand, right? Because it was a discount model, and in this model, you may have a factor where a price discount outweighs the savings of having an optimal Q over here, as we talked about last class. So one of the key elements of these models is that our demand is constant. So that is that every year the demand is, let's say, 12,000 units, and therefore we can calculate our daily demand, which is a function of the number of working days per year, and it's constant. So there's no problem in trying to do these kind of calculations. But what happens if we have a situation where demand is not so constant? How do we calculate what the reorder point would be, what the optimal quantity would be? How does that affect these kind of calculations? And in fact, we do have some models for that. We've got two models that we're going to talk about here, which is part of the course. Two models that are known as the probabilistic models, probabilistic. And what that means is that the D, the annual demand, is not constant, it's variable. So how do we manage the inventory when D kind of changes from month to month or even sometimes day to day? So there's two models that we're going to look at. The first is the service level model, and the second is the single period model. So these are two different models. Let's take it one by one. We'll look at the service level model first. Okay, so we've got the service level model here. So in this case, we've got a demand which is variable. And if you remember from the previous models, we have a kind of a formula for reorder point. So the reorder point, if you remember, is equal to our daily demand times the lead time, And I think last class I may have called lead time L. The book actually calls it lead time like this, but it's the same thing, it's lead time. Daily demand times lead time. So that's how we calculate our reorder point. And if you remember from last class, the reorder point is the point where your inventory drops to a certain point, and therefore you want to reorder so you don't run out of stock. But that all assumes that our demand is constant. But what happens if our demand is in fact not constant, but is kind of an average, which we kind of use a bar. Let's put a bar there. But D is actually on average maybe 5 units per day, could be 6 units per day, could be 2 units per day, but on average it's 5 units per day. And therefore we have a problem because we may not order at the right time. So how do we manage that? We manage that by adding a bit of a buffer stock. And in inventory management, we call buffer stock, in fact, safety stock. So it looks like this. We're going to add a term, safety stock, to calculate our reorder point such that we don't have a stock out. That's all it is. So that's what this model is all about. And why do we call it a service level model? Because we can never guarantee, because this is an average value, we can never guarantee that we'll never have a stock out, but we can guarantee a certain service level based on the parameters of this average value, and we'll take a look at that. We'll take a little look at that. And by the way, we certainly will do a sample problem of this model as an example. So this entire model, it's a very nice model. There's one formula, very straightforward, but the whole model is based on the normal curve, the normal distribution. And what we can do is, based on our standard calculation of reorder points, which is normally D times lead time, we're going to add a safety stock factor. And that safety stock factor is, guess what? A function of Z, which comes from our normal curve, and a sigma, which has to be given to you from the problem. So we have a sigma, which is from the lead time, and we've got a Z, which is the service level that we want to maintain, the service level we want to maintain. Let's take a look at that a bit further. So here's the very, very nice formula that we're going to use to calculate reorder points. And notice that we have one formula and we're given all the data. Usually we're missing only one element, and we need to plug in the right values to solve the problem for what is reorder point. Let's take a look at those variables. So of course, here's our reorder point, same as before. This is our average daily demand. Notice that it's a D bar now. Same as D, but it's average. That's why we put the bar. No other reason than that. Lead time is the same as before. We need to be given the lead time. And I'll just jump to this. Here's a sigma, because it's a probabilistic model, which is the standard deviation of daily demand. So again, that has to be given to you, which is essentially a function of if our D is, let's say, 5 days, could be 4 days, could be 6 days, could be 2 days. That variability is what drives the value for sigma, and that value is given to us, so not a problem. The only value that remains is, guess what? The Z value. So where do we get the Z value? Well, in these problems, we need to know what service level do we want. What service level do we want? So if we want to maintain a 98% service level, then guess what? We can calculate Z for 98%. If we wanted to maintain something less, perhaps 75% service level, same thing, we can calculate a Z for 75. Similarly, the opposite of the service level, and I'll just show you on this chart here. So if the service level is 0.98, that means that there is a risk that we will stock out, even if it's small risk, 0.02. So sometimes you're given the information like this, where you want a 98% service level. And sometimes you're given the information here, which is, I want a maximum stockout risk of 2%. So both are related. If you have one of these, you can calculate the other. And once you have one of these, you can then get Z. So for example, let's say desired service level is 98%. This means that also the probability of stockout is 2%, which is the complement of that. And if you look at your Z table, which is the back of the text, look at your Z table, the same one we used for project management. So if you take a look at your Z table, which I'm doing right now, as we speak, you go to your Z table, let's say the white textbook page AP6, go to your Z table, and for 0.98 probability, you get a Z of 2.05. So this is fantastic. We have everything we need to calculate this reorder point. So let's do an example. Here's an example. Look at it together. This is problem 1229. A supermarket is open 360 days per year, number of working days per year. Daily use of cash register tape averages 10 rolls. So this is a daily demand, and it's 10 rolls. And look, it says normally distributed, which is kind of an indicator that it is a probabilistic model. Here's another standard deviation of 2 rolls per day. The cost of ordering tapes is $10 per order, and holding cost is 40 cents per roll. The lead time is 3 days. And the question is, what is the EOQ? Just clear that. And what reorder point will provide a service level of 96%? So I think we can do that now. I think we know how to do that. Let's try. So part A is the same as before. So we know that EOQ equals, from last class, we know that it equals 2ds over h square root, right? 2ds over h square root. We have everything we need. We've got d, which comes from little d, right? We have daily use of 10. We have s, which is given $10 per order. Here it is. We've got h, which is 0.40 cents rolls per year. We have everything we need to calculate EOQ. The only thing I wanted to mention is that, of course, here we need big D. So big D equals little d, which is 10, times, guess what? Number of working days per year, which is 360, which equals 3600. So we have everything we need. We have everything. If we do a little plug and chug, now that we have everything, I did it. EOQ, nothing new here, same as last class, equals, going into my math, 424 rolls. Nothing more than that. Okay, tout le monde? And by the way, I did post this solution, so you can also take a look at Moodle at my worked out solution. Okay, next. The more important question is part B. Part B is, what reorder point, just clear that, what reorder point will provide a lead time service level of 96%? So the first thing we want to do is, the service level of 96% means, let's draw a little normal curve. So here, all this service level is 96%. So we can then get Z. So Z equals, from our table, 1.75. 1.75, just as before. So look at your normal table, look at 0.96, and you will see Z is 1.75. Nothing more than that. So guess what? We have everything we need now to solve the problem. Everything we need. So let's do that. So we have the formula, the fantastic formula. I'll just go back here. There it is. We're going to use that formula. And the formula is a bit tricky to write on the screen, but I think it's okay. D bar times L, lead time, plus Z sigma D, square root of lead time. Look at this. We have everything we need. We have D, lead time, Z, sigma D. And if we plug in the values, we get 10 times 3, it's all given, plus 1.75 times 2, right? 2, which is the sigma d, times the square root of the lead time, which is 3, which equals, if you do the math, I get 36. So the reorder point is 36 units. 36 units. And that's it, tout le monde. So I hope that was clear. I'm going to do a separate video now on the second model. So stand by for that. Part 2 coming up. Thank you.